Good morning, students. Today I am going to deliver a lecture on structural designing 1. We know that structural designing is a vital part which comes under a branch civil engineering. So, on the basis of structural engineering, I am going to explain a lecture on deformation of a body due to force acting on it. जब एक बॉडी डिफॉर्म होता है when we act a force. So today I am going to explain very briefly. So let us consider a body. This is a rectangular body. When we apply a force on this type of force, that is pull force, we pull the body, then such type of force is called as tensile force. When the body, rectangular body, when we pull on the both sides of the body, that corresponding force is called as tensile force. And consider the similar body. When we apply a push force on it on the both sides of the body, when we apply a push force on the both sides of the rectangular body, then such type of corresponding force is known as compressive force. So this type of force, when we pull both sides of the body, then that much of force is called as tensile force. And when we push the body, or when we apply the push force on the body, that much of force is called as compressive force. Start. So students, let us consider a body. Okay, that type of body, rectangular body, we consider this body and we apply a force on it, and how much it will deform, now we have to going to calculate. Okay, so here we consider P. Here we consider P as the load. How much load we apply on it, that much is known as P, and L is known as length of the body. And area is designated by A, and here this is called go. And area which is designated by A, this is called as cross sectional area of the body, or we can say bar. And now we go to learn that is E. E is called as Young's modulus, or modulus of elasticity. And Young's modulus, which is designated by E, this is called as modulus of elasticity or Young's modulus. In numerical problem, the value of E is already given in that question. So P is the load on which amount of load we act on that body, and L is the length of the body, and A is the cross sectional area of the bar, or we can say the body, cross sectional area of the body, and T is the Young's modulus. So now we are going to calculate the deformation of the body. So we designated as del L is called deformation. Del L is deformation. How much the body will deform, that much we have to calculate, that is del L. We calculate the del L, and we already know that sigma is called as stress induced by the body. Okay, the stress is induced by the body, and last but not the least, that is epsilon. Epsilon is strain. Strain is induced by the body. Okay, So I am repeating students, P is the load, how much we apply the load, how much amount we apply the load on the given rectangular section, and L is the length of the body that is designated by L, and A is the cross sectional area, we have to find the area of the bar of the body, and E is the Young's modulus, and del L is the deformation, how much the body will deform, we are going to calculate, and sigma is the stress induced by the body, how much the stress will be induced by the body, and sigma epsilon is strain induced by the body. And the student, we already know that stress is sigma, which is known as P by A, which is equation number 1. Stress is P by A, the amount of load per area, force per area we can say, and strain is designated by epsilon, that is del L by L, which is equation number 2. So the strain is amount of change of length by original length, amount of change of length, that is deformation, that is del L by L, and here we can write that del L equal to epsilon L, it is equation number 3. And now Young's modulus, that is E is sigma by epsilon, which is equation number 4. These are very most important, that is stress is sigma, which is equal to P by A, which is amount of load per area or force per area we can say. Strain is the amount of change of length by original length, which is going to be calculated sigma del L, and here we can del L equal to epsilon L we can write, and Young's modulus is P is equal to stress per strain or sigma per epsilon. And now we put the value of sigma in equation number 1 in the equation number 4, that is E is equal to, that is what, P by A. Here we just apply the value of sigma P by A, here we apply this much only, and now del L equal to E and L, okay, del L equal to E and L. And here we can write that epsilon is equal to P by A E. This is very much important. Okay. Now we can write that del L equal to this much. So from equation number 3, that del L is equal to how much? Epsilon and L, and the value of epsilon is P by AE, so we can write that P by AE into L, and finally our formula becomes PL by AE. We have to box it, that is del L is equal to PL by AE, which is going to be calculated. So students, the deformation, how much will deform when we apply a load on the corresponding body or the bar is PL by AE, PL upon AE. So P is corresponding stress or corresponding load applied on the body, and L is length of the body or bar, and A is area of the corresponding body, and E is Young's modulus of the body, or Young's modulus is already given on that numerical problem. So students, this much only we are going to calculate, and this is already we find that del L is equal to PL by AE. So now I am going to solve a numerical problem, and on this basis so much of numerical questions are probable questions are there for upcoming examinations. So we are going to perform a numerical problems. So students, this is the numerical problem that I have written in blackboard, that is a steel of 1 meter long. So here length is given, students, 1 meter long, and 20 millimeter into 20 millimeter in cross section. means this much is your area, or we can say this much is your cross sectional area, and is subjected to a tensile of 40 kilonewton. Tensile force, I have already said that tensile force means pull force, when we pull a corresponding sides of the body, or we can say bar. So the on that corresponding body 40 kilonewton applied on load, or load is designated by P. So P is given that 40 kilonewton. Now determine the elongation of the steel rod if modulus of elasticity of the rod, modulus of the elasticity of the rod is 200 GPa. So this type of question may come in your semester exam point of view. So now what is the solution? Okay, so you have to write in the given format, that follow my format, that is answer. So first of all you have to write given data. Given data. What is given? What does the data is given? I am going to write. So long, that is length. We can say that length which is designated by L is 1 meter. 1 meter. Okay. And now cross sectional area, that is A. Area A is 20 mm into 20 mm is equals to 400 mm square, and last tensile force, that is force I have write, that is P, that is 40 kilonewton. Everything all are in SI unit, so I have calculated in Newton only. Kilo means 10 to the power 3, so 40 into 10 to the power 3 Newton. And last, modulus of elasticity, that is Young's modulus. E, which is designated by E, that is given 200 GPa. That is 200 into 10 to the power 3 MPa. I have converted into MPa. Okay. So this is the given data. So given data is length, which is L, is in meter format. I have converted into millimeter. Everything is in millimeter, so I converted into millimeter. And area A is 400 mm square, 400 mm square. We have multiplied it, and force P, or we can say load also, tensile force or tensile load, that is 40 kilonewton. I have converted into Newton, 40 into 10 to the power 3 Newton, and Young's modulus is given that 200 GPa. G is gigapascal. We have converted into megapascal. When we converted into megapascal, then multiplied it with 10 to the power 3. So 200 into 10 to the power 3 MPa, that is megapascal. Let's now to find out what have to be found. What is we are going to found, that is determine the elongation of the steel rod, that is nothing but del L. We are going to found, or we are going to calculate del L. So we already know, that. So what is the formula, students? Del L is equals to PL upon AE. Del L is equal to PL upon AE. We put all the formula, okay, all the values of P and L and A and E. So how much P is given, that 40 kilonewton, we converted into Newton format, that is 40 into 10 to the power 3. Okay, now length is given in meter format, we converted into millimeter format, that is 10 to the power 3 millimeter. 10 to the power 3, and by area is cross sectional area 20 millimeter into 20 millimeter, which is given as 400 millimeter square. Okay, 400. And now E is nothing but Young's modulus of elasticity, which is given as 200 GPa, and I have converted into MPa, megapascal. When we convert gigapascal to megapascal, we only multiply with 10 to the power 3, that is 200 multiply with 10 to the power 3, and write 200 multiply with 10 to the power 3. So whenever we calculate this, 10 to the power 3 and 10 to the power 3 get cancelled, and 106 और एक 0 cancel हो गया. Whenever we put the calculator, when we put this much of value, then we got a value that is 0.5. And students, we are not confused. Okay, del L, which is deformation of the body, how much it will elongate. Whenever length is given in meter, we convert it into millimeter, and whenever area is in millimeter and force is also in Newton format, so our elongation of the body is also in form of millimeter. Okay, nothing to worry about units. Okay, you have to understand that what is the unit. When we if I not converted into meter to millimeter, then it is in meter format, or this is also in auto converted into meter format, then it is del L is also in form of meter format. Whenever we calculate in millimeter format, our answer is in millimeter format. So finally, this is our required answer. So students, this much we going to study about what is the deformation of the body, and we in this session we are going to already known about what is del L, what is the formula P, and what is PLAE. Okay, so del L equal to PLAE, and this is a small of numericals which may or may not come in your exam point of view. So thank you.